Hi everyone, welcome to Vocal Academy. See this problem, here open loop transfer function given here, that is g of s, h of s. So for that function, how can you find the gain margin? This is the problem. So first of all, understand what is gain margin. So if you find the magnitude, means the magnitude of g of s, h of s. So after finding magnitude, inverse this magnitude. But this magnitude was calculated at phase cross frequency. So at phase cross frequency, find the magnitude and apply inverse. So that value is called as gain margin. So for that, first of all, find the phase cross frequency. So then with the help of that frequency, find the magnitude, then apply inverse, then we get gain margin. Now let's see here how to find phase cross frequency. Now how can you find phase cross frequency and what is phase crossover frequency? So the frequency which gives the phase angle is minus 180 degrees, that frequency is called as phase cross frequency. That is phase angle of g of s, h of s function is, it gives minus 180. At certain frequency, that frequency is called as phase crossover frequency. That means find the phase angle. So from that we can simplify it, omega value, that is called as omega pc value. So by equating to minus 180 degrees. So let's see here. So first of all, replace s with j omega. Then equation becomes as g of j omega into h of j omega, that's equal to 1 by s means j omega into 1 plus j omega by 2, here 1 plus j omega by 10. So when you observe carefully here, this is one complex number, this is another complex number, this is another complex number. So here the real part is 0, that is 0 plus j omega. Now here how can you find the phase angle for this? So here the three complex numbers are producted. Now how can you find it? So let's see here, this is a standard process of finding the phase angle. So this is, so whenever the complex numbers are be in this form. So first of all, phase angle for this. So for this complex number, the phase angle is tan inverse of b by a plus, for this tan inverse of d by c, sum of all the phase angles in the numerator minus of sum of all phase angles in the denominator. So this is a process of finding the phase angle. So now apply this process to be here, then we get, so in the numerator 1 is real part and imaginary part is 0 plus j. So tan inverse of imaginary part is 0 by real part is 1. This process. Okay. There is no more complex numbers here. Now apply minus of. Now for this, the phase angle is tan inverse of complex part is omega, that is imaginary part is omega, real part is 0, plus for this phase angle, that is tan inverse of, so j coefficient is omega by 2, so omega by 2 by 1, plus tan inverse of here omega by 10 by 1. Here tan inverse of 0 and 1, so 0 by 1 nothing but 0, so tan inverse of 0 is 0 only. So here for this 0 minus of, it becomes, so anything but 0 nothing but infinity, so tan inverse of infinity is 90 degrees, plus here tan inverse of omega by 2 plus tan inverse of omega by 10. So this is equal to minus 180 because we are going to find phase crossover frequency, that is minus 180. So here omega means omega pc. So at which frequency is called, at which frequency it gives minus 180, that frequency is called as phase crossover frequency. So here minus minus cancel. Now it becomes tan inverse of omega pc by 2 plus tan inverse of omega pc by 10, that's equal to 180. So bring this 90 on the right hand side, it becomes minus 90, it becomes 90 degrees. Now use calculator for getting omega PC value. So by using calculator, by simplifying this, we will get omega PC, that is omega PC equal to root 20 radians per second. So this is the phase crossover frequency. Now at that frequency, we are going to find the magnitude. Then apply inverse. That value is called as gain margin. Now let's see here. So magnitude for G of j omega h of j omega, that's equal to 1 by, so this is j omega. So make it as 3 parts, because this is one part, this is one part, this is another part. That is 1 by j omega into 1 by 1 plus j omega by 2 into, because all are multiplied, these complex numbers, into 1 by 1 plus j omega by 10. So for ease simplification. Now find magnitude for this. So it becomes 1 by root of sum of the squares of under square root of complex part. That is, here the real part is 0. So 0 square plus j omega square. Now for this magnitude, 1 by root of 1 square plus j omega by 2 whole square. Next into, for this, 1 by root of 1 square plus j omega by 10 whole square. So we want magnitude at omega PC. So omega PC, omega PC, omega PC. So it becomes 1 by root 20 and it becomes 1 by root 6 and becomes 1 by root of 1 by 2. Just directly I am substitute the omega PC value and using calculator we will get this value. Now finally, by using calculator, by simplifying this, we will get it as 1 by 12. So this is the magnitude, but here we want gain margin. So gain margin is equal to inverse of magnitude which we got at phase cross frequency. So at phase cross frequency, this is the magnitude, that is 1 by 12. That is gain margin equal to 12. Suppose in some problems they will ask find gain margin in decibels. Okay, suppose if you want to convert gain margin into decibels, so let's see here. For finding gain margin in decibels, we have standard formula, that is gain margin in decibels, that is equal to minus 20 into log of 1 by this gain margin value. This is in dB. That is minus 20 into log of 1 by gain margin got 12. So by simplifying this we get 21.58 dB. So this is the gain margin in decibels, this is the gain margin now value, and this is the gain margin in decibels value. In most of the problems, gain margin will ask to find in decibels only. So don't forget this, this is very important. So mostly gain margin is measured in decibels only. So most of should you need to convert into gain margin in decibels. So this is the process of converting gain margin into decibels, and this is the process of calculating the gain margin. And thanks for watching. Please subscribe, like, share. Thanks.